Good morning, wonderful, amazing, fantastic algebra students. This is Ms. Youngblood here, bringing you today's review topic for Friday, March 27th, which is finding interquartile range in box and whisker plots. So let's jump into the assignment that was posted on Google Classroom. So looking at number 3 on the assignment, the first 4 problems just ask you to find the lower, upper quartiles and the interquartile range. So we're going to review how to do that. I jumped to problem 3 because in 1 and 2 you're just given a table of values and a dot plot, and I believe that we're familiar with being able to write out the list of numbers given those things. So I want to review how to write out the list of numbers giving a stem and leaf plot before we find the lower, upper quartiles and the interquartile range. So problem 3, we're given a stem and leaf plot for the minutes to run a 5K, and we're given a key at the bottom that describes how to read the stem and leaf plot. So this key tells us the stem is the tens place, the leaf is the ones place. Therefore, if we had something such as this, 3 line 1, that is equal to 31. So the first number in our data set is 1, 7, so that translates to 17. Next number is 2, 6, that's 26. Next number is 2, 8, that's 28, and the rest of the values that I obtained from this stem and leaf plot are here. 31, 2 34s, 35, 36, 37, 38, and 45. So again, these numbers just came from this stem and leaf plot. So now we want to find the lower quartile first. The lower quartile is the median of the lower half of the data set. Keep in mind the median is the number in the middle. So to find the lower quartile, you have to start by dividing the data set into 2 equal halves. Since there are an odd number of data values, we're going to keep one out in the middle and use the remaining numbers to divide it into 2 equal halves. So for this particular data set, there are 11 values. The first 5 numbers, after they've been organized from least to greatest, will be the lower half. The last 5 numbers, after they've been organized from least to greatest, will be the upper half. To find the lower quartile, we're going to find the median of just the lower half, just the first 5 numbers. So the first 5 numbers go from 17 to 34, and we see the number that is in the middle, the data value that is in the middle, 28, is going to be our lower quartile. We do the same thing with the upper quartile, and the middle value of the given numbers in the upper half. So again, we're looking at the top 5 numbers. The middle value for those top 5 numbers is 37. So the upper quartile is 37. Lastly, to find the interquartile range, you just subtract the upper and lower quartiles. For this particular problem, we're going to do 37 minus 28, which gives us an interquartile range of 9. Now I'm going to jump down to problem 6. 1 through 4 ask you to find the lower and upper quartiles in the interquartile range. Problems 5 and 6 So again, problems 5 and 6 are asking us to create a dot plot or a box and whiskers plot. To create a box and whiskers plot, there are 5 statistical measurements that you must find. So we have to find the minimum, the lower quartile, the median, the upper quartile, and the maximum. So we use those 5 statistical measurements to create a box and whisker plot that better organizes the data into quartiles. So in my class, we learned that each of these parts, these 4 parts, we have 2 parts of the box and 2 whiskers, represent 25% of the data. So it's just saying 25% of the data is in this range, 25% is in this range, and this range, which adds up to 100% of the data. So 100% of the data is represented in this figure from the minimum to the maximum value. Okay, so to create our box and whiskers plot, again, we have to start by finding the minimum. First, for problem 6, it was given to us in a table, so I had to write them in order from least to greatest. Lowest value I saw was a 1, so I wrote 1, 1. I saw 1, 2. I saw 1, 3. I saw 3 4s. I saw 1, 7. It's kind of blurry. 1, 7. and 2 8s. So again, they have to be in order from least to greatest before you begin this process of finding the lower and upper quartiles as well as the median. The minimum is the smallest value. Our smallest value is 1. The Q1 lower quartile is the median of the lower half. So we had a total of 9 values in this data set. So in the lower half, we're going to have 4 values. Again, because there's an odd number, we keep this 4 out in the middle. So this middle value for the whole data set was the median. So we exclude that when we're creating our lower and upper halves. Our lower half is the first 4 numbers before we get to the median. So that's 1, 2, 3, 4. So to find Q1, the lower quartile, we need to find the median of that lower half. Because there are 4 numbers, the median is going to lie between the 2 middle numbers. So we say 2 and 3 are both in the middle. What number is right in between 2 and 3? That number is 2.5. So our lower quartile is going to be 2.5. Again, sometimes it might be a little more challenging to find the lower quartile. So if it's not as easy to see, what you would do is add the 2 values that are right around it. So I did 5, or 2 plus 3 divided by 2, which gets us 2.5. So that's our lower quartile. Again, we already said the median was 4. There were 9 values, so the 4 is directly in the middle of the whole data set. The Q3 upper quartile is the median of the upper half. So the last 4 numbers after the median. That's the 4, the 7, and the 2 8s. Again, because there's an even number, we look for the number that is directly between the 2 numbers in the middle, which happen to be 7 and 8. So right in between 7 and 8 is going to be 7.5. So the upper quartile, or the median of the upper half of the data set, is going to be 7.5. Again, if you're struggling with visualizing where that is on the number line, algebraically or mathematically, you can just add the 8 and 7 and divide by 2. 8 plus 7 is 15. 15 divided by 2 is 7.5. 7.5 is directly in between 7 and 8. The last thing we have to find is the maximum value. So the maximum value is the biggest value in the data set, which happens to be 8. Then you want to plot these values in a box and whiskers plot. For the problems, I'm always going to tell you what scale I want you to use, just so that we're more consistent and it's easier for me to interpret where you are. So for number 6, I ask you to go from 1 to 8 and to increase by intervals of 1. So that means on the number line I'm drawing, I'm starting at 1 and I'm going up by 1s. So I have 1, 2, 3, 4, 5, 6, 7, 8. That's what that interval would translate to. And usually I want you guys to be able to understand you don't have to always do it this way, but they're usually only going to number like every other tick mark. So each of these is going up by 1. This is 1, 2, 3, 4, but instead of marking 1 and 3, I just mark 2 and 4. But that still communicates that each of these distances or each of these tick marks is increasing by 1. And I just went ahead and plotted the 5 measurements that we found. So the minimum was 1. I put a point at 1. The lower quartile was 2.5. So for the 2.5, the lower quartile, I'm going to put a line to start my box. The median was 4. I put another line to represent the halfway point for the box at 4. The upper quartile was 7.5, so I put another line in between 7 and 8 to represent the end of the box. So this box represents 50% of our data, and the maximum was 8. So I put my last point at 8 to represent the maximum. So again, each part of this box and whiskers plot represents 25% of the data. 25% here, 25% here, 25% here, and 25% here. Now let's take a look at some of the Khan Academy problems. I give you 2 problem sets. The first one is just calculating the interquartile range. So in my first problem, they gave me a dot plot that represents the songs on each album in Shane's collection. And they ask you to find the interquartile range. So again, we know how to read dot plots. This means that there is 1 7, there are 2 9s, there are 3 10s, 1 11, 2 12s, and 1 14. So I went ahead and wrote those numbers out so I could better see what their upper and lower quartiles were in order to find the interquartile range. So there were a total of 10 values, so I was able to split them into 2 halves of 5. The lower half is 7, 9, 9, 10, 10. The upper half is 10, 11, 12, 12, 14. Again, both halves have 5 values. Q1 is the median of the lower half. The number that is in the middle of the first 5 values is 9. So the lower quartile is 9. Q3 is the median of the upper half. The number that is in the middle of the upper 5 numbers is 12. So the upper quartile, or Q3, is 12. Lastly, to find your interquartile range, you just subtract Q1 from Q3, or you're doing Q3 minus Q1. So we do 12 minus 9, which gets us 3. So the interquartile range for this first problem was 3, which I already checked. The next problem in my set is given to me like this. So again, you always have to order your data values from least to greatest. I'm going to go ahead and do that, but again, this is how it was given to me. So we're going to order them from least to greatest. So this is what I got after ordering the numbers, sorting the numbers from least to greatest. I started with 2.9 and ended with 8.2. And then to find the interquartile range, I had to find the median of the lower half. So we have to start by dividing it in half. There were a total of 10 values. So the first 5 numbers, 2.6, 3, 4.9, 5, and 5, are the lower half. The middle value out of those 5 numbers is going to be 49. So the Q1 is 49. The upper half is going to be the last 5 numbers, 6, 6, 7.9, 8, and 8.2. The middle values for those is going to be 7.9. So then to find our interquartile range, I just did 7.9 minus 4.9. And I just want to make sure you guys can actually see what I was pointing to. 7.9 minus 4.9. So again, we subtract those 2 values to get an interquartile range of 3. So I did want to show my last problem because it's a little bit different. Not too bad. You guys could have figured it out. But just to give us a little confidence. On this last problem, there are 8 data values. So to split it into 2 halves, we're going to have 1/2 of 4. Excuse me. And a lower half of 4. And a lower and upper half of 4. So the lower half, the first 4 values, 32, 34, 35, and 35. You want to find the median of the lower half to find Q1. The median is going to lie in between 34 and 35. The number right in between 34 and 35 is 34.5. For Q3, the upper quartile, which is the median of the upper half, we're looking from 39, 40, 44 to 47. 44 and 40 are the 2 numbers in the middle. The number right in between 40 and 44 is going to be 42. So the upper quartile is 42 and the lower quartile is 34.5. When you subtract those values, your interquartile range should be 7.5. So that was our final answer for that last problem. Again, the only difference was that there was an even amount of values in the 2 halves. So to find the lower and upper quartile, we had to go right in between 2 of the values. Again, we did that in our head by imagining a number line, but if you want to do it algebraically, you add those 2 values and divide by 2, like I showed earlier in the video. In the next problem set, we are creating box plots, which means we have to know how to find the minimum, lower and upper quartiles, median, and the maximum. So in this first problem in my set, they give us a data set with 11 values, I believe. Yes, 11 values. So again, you want to start by identifying the min, max, median, then the lower and upper quartiles. So the minimum, our lowest value is 54. Our maximum is 76. Our median is the middle number. So as I said, I counted them. There are 11 values. So we're going to have 1, 2, 3, 4, 5 on one side. 1, 2, 3, 4, 5 on the other side. So the median of the whole set is 69. To find the lower quartile, or Q1, we're looking at the median for the lower half, the first 5 numbers. So we see the first 5 numbers here, 54, 60, 65, 66, and 67. The middle number, the Q1, is going to be 65. We do the same thing for the upper quartile using the upper half. So we have 70, 72, 73, 75, 76. The median of the upper 5 numbers is going to be 73, so our upper quartile is 73. So we have those 5 values, and then we just have to find the box plot that match with that. So I scrolled down to C and saw that C had a minimum value of 54, a lower quartile of 65, a median value of 69, a upper quartile of 73, and a maximum value of 76. So that's why this box and whiskers plot represents this data correctly. In the next problem in my set, we're working backwards. They give us the box and whiskers plot and then ask us to find a data set that could be represented by this box and whiskers plot. So to find the corresponding data set, I started by determining the 5 key points from the box and whiskers plot. So the minimum of this plot is 24, the lower quartile is 27, the median is 31, the upper quartile is 33, and the maximum is 34. So since the min is from 24 to 34, I automatically know that A will not work. The next key part I looked at was the median. The median has to be 31. All of these data sets had 11 values, so I just looked at the middle numbers for B, C, and D. The middle number for B, 1, 2, 3, 4, 5. Was it 9 or 11? Oh, I believe they had 9. Yes, they had 9. I misspoke. So it should be 4 on each side. So 1, 2, 3, 4. 1, 2, 3, 4. Median for this one is 30. That's not right. Same thing here. Median for this one is 30. This is the only data set that has a median of 31, which is required by this box and whiskers plot. Therefore, the only answer that's going to work is D. The rest of the problems in the set seem fairly similar to the problems that I've already done, so I'll let you guys figure those out. And if you have questions, you can comment on this video below, post on Google Classroom, send me an email or a text if you need help with your specific problems, as well as if you need help, with the handout that's posted on Google Classroom. I want to end this video by looking at the daily reflection question for yesterday and reading today's daily reflection question before I do my post later in the day. So yesterday's daily reflection was, would you prefer to be a successful business owner or make valuable contributions to someone else's business? My response to that reflection was, I have never had the strong desire to start my own business. I believe that becoming a successful entrepreneur requires a certain level of discipline and desire to provide a service that is necessary and innovative. During high school, I recognized my passion for education. I wanted to assist in finding ways to make education, math specifically, more accessible and meaningful so that more students could truly identify what they are passionate about and use that passion to find and follow their dreams. There are already so many institutions and businesses with a similar goal that I believe it would be a better use of my time to assist them in their endeavors than embark on my own journey. If there comes a point in time when I don't believe the work I am doing for institutions is making meaningful strides in accomplishing my overall goal, then I may have to step out and create my own business that does. And the daily reflection that I will be responding to later at some point today through Google Classroom is going to talk about how would I describe my current situation and what is my next destination. Again, that response will be on Google Classroom, but I'll also post it on Monday. I'm still debating if I'm going to make a video for Monday. I actually probably will not. So my next video probably won't be until most likely Wednesday. I might shoot for Tuesday, but most likely Wednesday when I start introducing more material. Again, I'm still awaiting for directions from the principals to see where we're going as far as the closure, but I'll be posting things as long as they're allowing me so that you guys can continue taking your education seriously if you're able to, and getting, this is just another resource you can use to continue strengthening your math skills. If you have any questions about the math that we went over, the daily reflection, my song of the day was Faithful by Hezekiah Walker for today. for yesterday, excuse me. So yeah, if you guys have any questions, feel free to comment on this video, Google Classroom, send me an email or send me a text. Thank you for taking the time to watch, and I will see you next time. Bye.